A scatter plot is a graph showing a relationship between two data sets, right? So it's like all those points showing the relationship between two data sets. We graph the data as ordered pairs. So like we'll talk about how to do this, but it's basically sets that show relationship between data. Of this is going to be being able to look at a scatter plot and interpret the data. So they'll give you information. So for example, this scatter plot shows the relationship between the amount of sugar and the amount of calories in various smoothies, right? So
left corner, it kind of got a little.
That's a good question. Do you guys see that down here?
The bottom left corner is a little.
So they just are starting the data not from zero. They're going to start it from 46 grams of sugar and 240 calories. So it like shows that it's not an even graph right there. It's just cut out part of the graph. It is kind of weird how that looks. So it's a little zigzag showing there's no data there. All right, so you can imagine that they maybe sampled smoothies from a lot of different locations and graphed the amount of sugar that each smoothie had and the corresponding amount of calories in that smoothie. So here's what it's going to ask, something like letter A. How many calories are in the smoothie with 56 grams of sugar? So what you have to do is find that smoothie. So if we look along our x-axis, which is where we're looking at sugar, and we find 56, which is going to be right in between here, right between 54 and 58, somewhere in there. So so if we go up from 56, then we find that smoothie. Yeah, so how many calories does that smoothie have when it had 56 grams of sugar? 270. So just interpreting based on the data that we're given, being able to read the graph. Or how much going the other way, how much sugar in a smoothie with 320 calories?
70.
Right, so we go all the way up to the calories on the y-axis, find the smoothie that has 320, and then we can drop down to see how many grams of sugar it has. So that smoothie has 70 grams of sugar.
With 70 grams of sugar in it.
And probably I feel like a Frappuccino or something.
That's not smoothie.
It's not a smoothie, but I feel like some people consider them a smoothie. What do you think? But I think, think about it. If you got, it doesn't also differentiate sizes. So, what if it was, a large smoothie that was, chocolate peanut butter? That could have a lot of sugar in it. Okay. We good with that? So, being able to read a scatter plot by looking at the data. All right. Now, think about this. If we were just sort of explaining the graph, if I erase all my little dots. What tends to happen as sugar increases? What do you notice on the graph? As sugar gets larger,
More calories.
correct, right? They also, as you have more sugar in the smoothie, then you tend to also have more calories. So the more sugar tends to equal more calories in the smoothie, right? So more sugar. As sugar increases, then calories also increase. All right, so the first part is just being able to interpret a given scatter plot, the data on the scatter plot. All right. Okay, vocab word, correlation, describes the relationship between the data sets. So if we start here, that's what we just saw, right? Those ones had a positive linear correlation. As X increased, as our sugar increased, Y also increased. So the calories increased. So it's a positive correlation. Think about this like slope, right? A positive slope rises from left to right. Positive correlation rises from left to right. So as x increases, y increases. This is also linear correlation because it follows the shape of a line. Zegan.
Can you just draw like a line through it and you don't have to do anything else if you see a problem like that and ask you to draw the line of best interest?
Yes, but here's what it's going to say. It'll say, what is the correlation of the data? You have to say it's positive.
Because it's going up?
Correct, because it's going
up. Would you say
up.
it's also linear? Because, I mean, it can be non-linear.
Correct.
It can be everywhere. Would you say linear, positive?
Positive, linear, yeah. Positive, linear. Most of this will be linear.
Say it was like flipped.
Yep.
And it was going like that.
Yep.
Negative.
Yes. Coming up next. Negative linear correlation. Notice how the line is going down like a negative slope. And it follows sort of a linear pattern. So it's a line. Oops, I have more that I can erase down here. Okay, so what happens in negative linear correlation is as x gets bigger, y gets smaller. Okay, and then the last situation we can have is no correlation at all. And that's when there's really no pattern in the data set. So like the points are just all over the place and they don't really show any kind of consistent pattern at all. So then we say there's no correlation.
It actually looks like it's negative.
No.
No, because there's also stuff going.
They're two all over the place. Yes.
Can there be non-linear?
There can be nonlinear correlation. So you probably won't see that, but what that would look like, would be, it would look like a curve of some kind, right? Or like exponential would be like, it would go up really fast like that. But again, it's got a curve, so it wouldn't be linear. It would be nonlinear. But generally, we'll be talking about linear correlation in this unit for now. All right, we good with that? So when you're asked to describe correlation, you're saying positive linear, negative linear, or no correlation. That's how the data will be related. All right, let's look at an example. Describe the relationship between the data. Another word for that is the correlation. Right, so look at this. This graph is showing data between someone's age, how old they are, and how many vehicles they own. So, according to this data, whatever this sample set is there a correlation between someone's age and how many cars that they own or vehicles?
No, not really. Not clear.
Not very clear. I would say that there is not a correlation because look how far apart all of those dots are. They're kind of all over the place. So, looking at this data, we would say there is no correlation. It really has to follow a tight, clear pattern for us to be able to say that there is correlation. And these are two all over the place. Okay, let's look at the other one. This one, temperature and coat sales. What do you predict? Will there be a correlation?
Yeah.
What do you think will happen? As the temperature gets higher, what will happen to coat sales?
They'll go down.
They'll go down because people don't need coats when the temperature warms. So let's see if our prediction is correct.
Wow.
Yay. So how would we describe this? Negative.
Linear correlation.
Yep. And specifically it's negative linear because it's in a line. Correlation. As the temperature increases, the number of coats sold decreases because it's getting warmer. Okay? So describing correlation is just giving a name to the pattern in the data. The line of fit, sometimes called the line of best fit, is a line, or more specifically, the equation of a line that closely models the trend of a scatter plot, that models that correlation. So it'll have a slope, it'll have an intercept, you'll always write it in slope-intercept form. using points on that scatter plot. So here's our steps. Step 1, plot the data if it's not plotted for you. Plot the data, or you can just use the table, right? Because we can write equations from a table. We can find the slope, and we can either, if there's an intercept, use slope-intercept or point-slope. So plot the data if you need to. Step 2, you need to decide if there is a correlation, because if there's no correlation, you can't write the equation of a line. So you can only write a line of fit if there is a clear correlation. If the dots are all over the place, you're not going to be able to write the line of fit because there won't be one. So then if you can, draw a line through at least 2 points, because we always need at least 2 points in order to write the equation of a line. And use point slope or slope intercept to write the equation. So like we've been practicing all chapter, you'll be able to find the slope from 2 points, and then you can use point slope or slope intercept and write the equation of the line.
Should we write these down?
No, don't write them down. Just watch how I do it. So first we want to determine, before we can write, I feel like I wrote something else here and I'm going to draw over it. Hold on. Okay, so we're going to write an equation and interpret the slope and the y-intercept. Okay. First, let's quickly just model the data and make sure that there is some correlation between our values. So our x value is down here. The year, 1, 2, 3, 4, 5, 6, 7, 8, and then subscribers. And we'll just do by like 10. We can kind of see it. This one's nice because it gives it to you in order. It won't always. And if we plot the data, just to make sure there's a correlation, so we've got like 1, 9, 2, 21, 3, 33. So what do you notice? Is there seeming to be a correlation here? Yes. Okay.
It's almost a straight line.
It is yeah, it almost is a straight line. It is a positive linear correlation. As the years go on, this website gets more subscribers. So here's what we're going to do. We need to write the equation that models this data. How many points do we need to write an equation? 2. Which points can we choose?
X, 2, and 3. And
Any 2.
0 and 1.
We can choose any 2 points.
0. I like 0.
So let's do these ones. Why not? 0 is always easy to work with. So here is, let's write these as an ordered pair. 0, 9, and 1, 21.
And then
In order to write the equation of the line, we need what? A y-intercept and a slope. Okay, so in this case, we have a y-intercept, but we just need to find the slope. So let's use slope formula, y2 minus y1 over x2 minus x1. So our slope is 12?
I would concur.
Yes. Okay, slope is 12. So then we can just plug this into slope-intercept form. Y equals 12x plus, what's our intercept? 9. Okay, so here's the equation that models this line, 12x plus 9. Now they're going to ask you, what does this, like they say, interpret the slope and the y-intercept? So we want to put this into terms that sort of tell us what this means in terms of this specific word problem. Zegan, what do you think?
Mrs. Lorizia, what
Yes.
if you change the two coordinates you use? Let's say you use the 5 and 6 x's
Yep.
and their pairs y. Wouldn't you get a different intercept and a different...
Correct. Yes, so this is a good question. You will get slightly different equations if you use different points, and that is okay because it's not an exact line, right? All these points don't lie on exactly the same line, but they'll be very close. So any of them are correct for part of that line of fit, as long as you're choosing 2 points that lie. No, go ahead. So
If it's like compounded interest almost, like when it's not going by the same exact, like, going up by 10, going up by 10.
Correct.
Goes up by like 14, then like 17.5
Yeah.
and that stuff. How would the slope be the same? Like, the slope's going to change.
The slope will be close. So, like, if we did these 2 points, for example, 5, 6, and 71.53, actually, it's going to end up being exactly the same.
Oh.
But it won't always, because what's 71 minus 53?
I have no idea.
Is it exactly the same?
This is why we need them.
No, it's not. It's 22. Where am I? Wait, no, I'm done.
Yeah, no.
Explain it.
11. Is that 8?
Wait, yeah, 20. It's 8. Wait.
Why? Oh boy. Math.
Yeah, but
Math is hard. 11 minus 3 is 8, 18. So this slope is 18x. That's pretty close. It's still a positive slope that's increasing. So it's going to be close. They won't be exact because this data is not necessarily exactly linear, but it's pretty close. It's following a linear pattern, even though it's not exactly all on the same line.
So you can get different slopes.
Correct. Correct. But they'll be similar. So now the second part of this asks us to interpret the slope and the y-intercept. What is the slope telling us in terms? How fast is this place growing? How fast is this website growing? About how many subscribers per year?
Oh, very slow.
Like 12 million.
Like 12 million, exactly. That's what the slope's saying, is it's increasing by
That's very unrealistic.
about 12 million subscribers a year. Right? Because that's the slope. That's what it's saying. Each year we're gaining about 12 million, give or take. Sometimes it's a little more, sometimes it's a little bit less, which is why if you chose different points, it might be a little bit different, but give or take. What is the intercept telling us?
This is like high two.
What? 9. And what does that mean in terms of this word problem? Where did it start? Yeah, good. Started with 9 million subscribers. And from there it started to grow by about 12 million per year. So that's what the slope and the intercept mean if you are asked to interpret.